All right, guys, here's section 7.1. We're only going to do a total of 4 sections out of this chapter, and we did the intro, this one, and then 2 more next week. And then we're going to move on to some other things for the last couple of weeks of school. So the amount of an annuity at the end of this class, do you know the meaning of annuity and how to calculate how much money has been saved? All right, that's about all we're going to focus on today. I'm going to change my color here to, let's say, blue. Sure. So here's the definition. An annuity is a series of payments made at regular intervals. So, like in the last lesson, I was reviewing with you like how much an investment would be worth if you just let it sit there and earn interest. But in reality, if you're saving money for a house or saving for retirement, or in your case, maybe saving for some education, then you're probably putting regular payments into it. So, examples: paying for a car over 5 years or depositing $100 into a bank account every month. Now, that's kind of like the type of investing that I do. So, for example, at the end of every year, Sam deposits $500 into a savings account that pays 4% compounded annually. What is the amount saved from the annuity after 4 years? So, we can't just use the compound interest formula for that. We could use this table. So, you start with no money, so therefore there's no interest earned. Then at the end of the year, you deposit $500. So, you have $500 at the end. You let that $500 sit there through that second year, and it's going to earn $20 of interest. Then you're going to put another $500 in the account. With the 500 original dollars, your new deposit, and the interest, you now have $1,020. That's 500 plus 500 plus $20. You repeat the cycle, so you start with that much the next year. It earns some more interest because you've got more money in the bank. You add another $500 to it, and again, you add those 3 values up, and that's your new starting balance. It's going to earn even more interest. You deposit more money, and so on and so forth. And that works fine for just a 4-year cycle, but usually you're not. When you guys are saving for retirement, let's say, like what I'm doing, is you're depositing some money, and you're hoping that you have a lump sum after, I don't know, say a 30-year career, something like that. So making a table like this, while you could certainly do it, I wouldn't recommend doing it. Instead, there's an easier way. Well, it's not going to look easier when you see it, but watch this. So it's A equals, that's the amount that you're going to have, times R times 1 plus the interest rate per compounding period, or the interest per compounding period, to the power of n minus 1. That's all in brackets together, divided by that interest rate again. So this is our annuity formula. I know it looks complicated, but really it's just plugging some numbers in. So A is the final amount that you have. R is the regular payment that you're making. I is the interest rate as a decimal per compounding period. So like you gotta, if it's annually, like in the example we did, it's just the interest rate in decimal. If it was semi-annually, you'd have to divide it by 2, quarterly by 4, monthly by 12, and so on and so forth. And N is the total number of compounding periods that you're looking at. So if it was 4 years annually, that's 4 times. If it was 4 years semi-annually, that'd be 8 times. So let's try and apply that formula. Again, it's A equals R, big bracket, 1 plus I to the power of n minus 1, all divided by I. So A is what we're trying to find. R is the regular amount. So you're putting in $500 each time. The interest rate is 4%, and it's annually, so we don't have to divide it up. We just have to convert it to a decimal. That's 4% as a decimal. And the number of times you're going to do it, if it's annually, if it's compounded annually, that's just once a year for 4 years, so it's 4 times. So this is about the easiest annuity that we could solve. So let's try and plug those numbers in. A equals 500 times 1 plus 0.04 to the power of 4 minus 1. divided by 0.04. So the first thing I'm going to do is I'm going to try and work out what's in the bracket there, the 1 plus 0.04. 1 plus 0.04 is, of course, 1.04. Then I'm going to go to the power of 4. Then I've got a number there. I'm going to write what I have here. So now I got 500 bracket, and I'm not going to write it all out because it's a big long decimal. It's 1.1698 and then some other stuff, minus 1 divided by 0.04. So next to my calculator, I'm going to type minus 1. It gives me 0.1698 and so on. And then I'm going to hit times 500 because that's what was in front, and then divided by 0.04. And it says I'm going to end up with, if I can fit it in here, 2,123 and 23 cents. I know for a 4-year annuity, you might be more comfortable with a table, but trust me when I say if it's a 30-year investment, a 15-year investment, even a 10-year investment, you don't want to make a table and go through that process. To fill in that table yourself, if I go back to it, this might have been a 20-minute question for you to solve with the table, even though it's only 4 years. So it just gets longer and longer. So you're going to teach yourself, or I'm going to try and teach you, and you're going to try and teach yourself to use this formula to calculate the value of these annuities. So let's try another one. How much would you have saved if you invest $200 each month? So that's 12 times a year, 2.4% compounded monthly for 5 years. So R, again, is $200. That's the amount you're putting in each time. I is the interest rate, so that's 0.024, just divided by 100. But it's 12 times per year, so I have to divide that by 12. 12 times per year because it's compounded monthly. So it's 0.024 divided by 12, which is 0.00002, I believe. You guys can double check that and chime in on the comments if I didn't do that right. The number of times that you're compounding is 5 years monthly. So 5 years at 12 times per year, and that's equal to 60 times. Now we just have to sub into that formula. Again, it's A equals R bracket 1 plus the interest rate to the power of n minus 1, all divided by I. Just for 5 years, $200 a month. I know it's probably a lot of money for most of us to save in a month and put in the bank, but if you could, this is what you could end up with in 5 years. So I'm going to finish down here. A equals 200. I'm going to sub all my numbers in. 1 plus 0.002 to the power of 60 this time, minus 1, all divided by 0.002. So I'm not going to write out the intermediate step this time. I'm just going to tell you what I'm doing. 1 plus 0.002 is 1.002. To the power of 60 is equal to 1.127 and a whole bunch of other stuff. Minus 1 is 0.12736,174. I took care of all of that big bracket stuff. Times 200. Looks like I have 260 written there. It's just 200 divided by 0.002. And it says I'm going to have $12,736.17. It's hard for people to put away money, but if you do, it can really add up. So what is that? Just after 5 years, you've got over almost $13,000 saved up. So this question would be different for everybody, but let's say, what can I actually afford to do? I'm going to do it for myself. I'm going to say I'm just going to put away $50 a month. $50 a month. So by the time I turn 50, well, let's say I did that just to make that more relevant to you guys. So I'm going to say that I started doing this at 20 years old. So that means I'm doing it $50 a month for 30 years. If I start when I'm 20 years old, so by the time I'm 50, what will I have? So the amount of money I'm putting in is $50. The interest rate is only 1.2%, which is 0.012% divided by, it's each month, so I got to divide it by 12. So I go back here because it's 12 times per year. 0.012 divided by 12, because it's monthly, it's going to be 0.001, and that's it. The number of times, it's 30 years. So I'm going to say it's 12 times a year for 30 years. So 12 times 30 is equal to 360. And now I'm going to my formula. A equals R. R is $50. Bracket 1 plus that interest rate, 0.001, to the power of 360 minus 1 divided by that interest rate again, 0.001. So let's see how much money I would have had at 50 if I started then. I'm 41 years old now, so it's a little late to start this process. 0.001. I wish I would have put this much away. So I went 1 plus 0.001, which is, of course, 1.001, to the power of 360. Gives me 1.433 and a bunch of other stuff. Minus 1 is 0.4330761 times 50, and then divided by 0.001. I would have $21,653.58 just from $50 a month. So what I want you guys to do is just practice using this formula, basically. Numbers 3, 6, and 10 were the best ones I figured for you guys to work on. Number 3, well, I'll show you what the questions are. The pain of it is they're on 3 different pages, all right? So on page 415, there's number 3 there. And it just gives you the formula and says, go ahead and calculate. It gives you some values and just practice punching the numbers into your calculator. Okay, so that's the first question I want you to do. The second one is number 6, where it just gives you some straight up 10 years, 7% per year, $3,000 deposited per year. And you just run the numbers that way. So then you have to at least come up with your own R, your N, and your I from the word problem. And then lastly, I think it's number 10 that I wanted you to go through and do, which is a word problem trying to save for college or university or something like that. But the same idea. You got to come up with the I, the N value, the R value, and then plug it into the formula, okay? Let me just make sure. Is that right? 3, 6, and 10? Yeah, those are the ones I wanted you to do, all right? So there's number 10 there. What's the amount at the end of the 18 years? So that's how much you're putting in at the end of each year. And an RESP, it gives you a percentage. It's compounded annually, so very easy to figure out what I and what N are for that sort of case. How much interest is earned? How much interest is earned is, what would you have normally if there was no interest on it, is 12,000 times 18 years. So just to show you what you're starting, so 1,200 rather, times 18 years would be $21,600. So that's how much you'd have if you just, stuffed it under your mattress, $1,200 each year. All right. So after you figure out what the answer is to A, the value of the RESP after 18 years, then how much difference there is between the 21,600 and that new amount is how much interest it earned. Okay. How much extra interest would have been earned if you change the interest rate to 7%. So basically you have to do the question again. And that's why I didn't assign any more questions. So you got to go through and do the part A again, basically with 7% instead of 6%, get the new total value, subtract the 21,600, and that's how much more, that'll tell you how much more interest that it earned. All right. I don't think you'll have any problems with it, but if you do, keep the emails coming. I'm happy to, I don't 100% of the time have my phone on me, but anytime I do, if I get a message from you guys, I message you right back with an answer. Okay. So keep those coming. page 415 and forward, number 3, 6, and 10. Please submit those. Try and submit them by the weekend, and then we're almost to the end of this course. We're going to do a little bit more next week in this same chapter on annuities and mortgages. And then we're going to circle back onto some trigonometry and what was the other thing? And geometry. And then the very last week of school, we're going to look at some different trade exams that will apply to you, and you'll be a kind of choose your own adventure situation there. So let's get out of this PowerPoint. I'll keep my annotations because I'm sure that they're amazing. And I'll sign off, guys. Good luck with the work, and keep your questions coming. See you soon.